Hi guys, this video is part 2 in concept series for JEE Mechanics. In this video, we will talk about a very important concept I have seen being repeated in many past JEE exams, and the concept is friction. In this video, we will learn how to get friction right in your exam. We will start with how to decide whether the friction is static or kinetic. Then we will talk about the rules and examples for both static friction and kinetic friction. We will also talk about the common mistakes or traps that students fall in. Then we will look at some past year questions from the JEE exams. So let us start with how this video is going to help you in JEE. Most mistakes students do, they are before you draw your free body diagram and set up your equations. And one common mistake is selecting the wrong friction force, that your assumption about the problem is wrong. And if you fix it, then it will increase your score. So the JEE is not just about math, it is about the concept. So let us start with how to decide static or kinetic. So memorize this. If there is slipping, and what does it mean by slipping? It means non-zero relative motion between the surface and the contact point of the body. If the answer is yes, if there is slipping, if there is non-zero relative motion, then there will be kinetic friction. If there is no slipping, if there is no relative motion between the body and the surface, then there will be static friction. Let us look at some examples. So we have fixed ground and we have a block, and that is at rest. So let us calculate the relative velocity of block with respect to the ground, and 0, because the block is at rest and the ground is fixed. So the relative motion is 0, so it is no slipping, and no slipping means it cannot be kinetic, it will be static. Block, the second example, the block is moving to the right with speed v block, as you see in the figure. So the block relative velocity with respect to the ground is to the right, right? So this is not equal to 0. So that means there is slipping, and if there is slipping, the friction will be kinetic. So no slipping, static, and if there is slipping, kinetic. Look at this example, that the ground is not fixed anymore. The surface is also moving with a velocity Vs. And in this example, the block velocity is more than the surface velocity. So the relative velocity V block minus Vs is greater than 0, which is not equal to 0. So that means there is slipping. And if there is slipping, the friction will be kinetic. Second example, the block is moving with a velocity that is less than the surface velocity Vs. So there is still relative motion, and which is not equal to 0. So there is slipping, and slipping means the friction will be kinetic, right? So go back here. Static, no slipping, kinetic, slipping, right? One more example, if the block is moving with the same velocity as the surface Vs, V block equal to Vs, then the relative velocity between the block and the surface is zero. And that means there is no slipping. And if there is no slipping, then the friction cannot be kinetic. It will be static. Now, if a problem statement says rolling without slipping, then the problem is telling you there is no slipping. So the friction will be static. So please do not miss that in the question. The question, if that says rolling without slipping, then the friction will be static. Now, so we learned how to decide whether the friction is static or kinetic. Now let us talk about what are the rules for static friction. So, static friction is not a fixed value. It can be anywhere between 0 and the maximum static friction, the maximum value, which is mu s. Mu s is static friction coefficient multiplied by n. N is the normal force by the surface on the body. And mu s multiplied by n is maximum value of Fs, static friction. So the static friction is between a 0, that means no friction, minimum value, and a maximum value. And the direction is in the opposite to the way the body tends to move. And we are going to look at examples. Here, first, what does it mean by the static friction is not a fixed value and its direction is in the opposite direction to tendency of movement? What is this tendency of movement and what is this range? So look at these 4 diagrams. First, the block is at rest, the ground is fixed ground, the block is not moving, and normal force by the ground on the block is N. Now, we apply a force F. We push the block to the right with a force F. And let us say that F is less than mu Sn. So mu Sn is a number, right? So that force that we are applying on the block is less than that. So if there was no friction, the block will start moving to the right. But there is friction, so the surface will apply a friction, static friction equal to F. And these will cancel out. Fs equal to F. And the block will still be at rest. Here, friction is 0. Right? Because the block has no tendency to move to the right or to the left. Then we increase the force F, and now we say this force we are applying is equal to the maximum value of static friction. So the ground will apply the maximum, the Fs, that will be the maximum mu Sn in the opposite direction, because without friction the block will start moving to the right. So this will cancel F and net force on the block is 0 and the block is at rest. So see how friction is adjusting itself. Here it is at 0. Here it is a less than maximum value and here it is maximum. And in all 3 cases, 1, 2 and 3, the static friction is there, that it is different value in all 3 cases, 1, 2 and 3. And in all 3 cases, the result is the block is at rest. Now, if we increase the value of force F and that force is more than the maximum static friction value, The ground cannot provide a friction value that is more than mu Sn. So this Fs will still be the maximum, right? Okay, and the block will start moving. And here is the interesting thing: when the block starts moving, there will be slipping, and because there's slipping, that means there will be kinetic friction. So this will convert into Fk, kinetic friction, and the block will start moving to the right. Okay, so now you see what it means by that static friction is between 0 and a maximum value. And once the block starts moving, the friction will convert into kinetic and the friction will become kinetic. So, what are the common traps or mistakes? Students often assume that static friction is mu Sn without thinking, which is not always. Okay, static friction can be anywhere between 0 and this maximum value. So remember that. So if you see static friction in the problem, just write Fs, not Fs equal to mu n. Wrong direction of friction. We will talk about another problem after this, and you will see how the direction of friction can switch, and ignoring the possibility that friction force is 0 even if the surface has friction. So it can be that Fs equal to 0 and surface is not smooth, surface is rough, but still it may happen that Fs is 0, right? So there is a possibility of that. So please do not ignore that. Fs equal to 0 can happen. Okay, and we will talk about that through an example later. Next, how to decide direction. You should start with the imagination that there is no friction. So imagine there is no friction, and and apply all the forces on the body. And if the body tends to move this way, it wants to move this way, then the friction will be the opposite direction. Friction, right? This is movement tendency. So tends to move, or the body wants to move to that direction. And if the body wants to move, it wants to move this way, right? The body is about to move to the left, the friction will be this direction. Okay, so start with the imagination that there is no friction. That is how you should start with. Now, let us look at a very good example, a car on a race track, an inclined road. So this is the inclination, right? So this is the inclination, like this angle is theta. And the car is going like this, the car speed, this is car speed v, right? So look at this example. So the car would need centripetal acceleration to turn, right? So if you look at the top view, this is the path. This is the path here, right? The radius of turn is r, and the car speed is v. This is the car speed. This is the car speed v. So the car would need an acceleration v square divided by r, which is called the normal acceleration or centripetal acceleration. Right? Now, what are the forces on the car, because these forces, they have to provide the normal acceleration v squared by r, right? So this is the view along this incline, right? This is theta. So here we see theta. So the gravity is applying the weight force downward, vertically down, and the track, the road, is applying a normal force on the car like this, right? So let us do some math. So this is theta, the inclination angle from the horizontal is theta. So this will be theta, this will be theta. So this force in this direction here will be n sine theta, right? Mg will not have a component, a horizontal component. And then we have n cosine theta vertically, right? So n cosine theta will balance mg, right? And one important thing, imagine there is no friction, because what we talked about, if you go back here, start with the imagination that the friction is absent. So imagine there is no friction, okay? So there is no friction, so there are only two forces, normal force and mg. So n has two components, one vertical n cosine theta and one horizontal n sine theta. So we can write n sine theta. This will provide this centripetal acceleration. So n sine theta, which is this way, it will provide m an, so that will be v square by r, right? And this is Newton's law, F equal to ma in this direction, right? In the horizontal direction, there is only one force, n sine theta, and the acceleration is v squared by r. And then we have n cosine theta equal to mg, because acceleration in this direction is 0. This direction is 0, right? And one more thing, we say there is no friction and we assume also no slipping, right? That means the car is not slipping down the slope or up the slope. There is no slipping down the slope or up the slope, right? So now from here, from these two equations, if you divide them, you will get n sine theta divided by n cosine theta equal to m v square by m r g, and m cancels out, normal force cancels out, and from here we will get tan theta equal to v square by rg, and from here we will get that v is square root rg tan theta. Now what does it mean? It means if there is no friction and we are saying the car is not slipping down the slope, not slipping up the slope, the car must be moving at this speed. If not, the car will either slip down the slope or up the slope. So our conclusion is that without friction, the car must move at this speed. So it will not slip up or down. This is slipping down. So it will not happen. And this is slipping up. That will also not happen. If the car is moving at this sweet spot, square root rg tan theta. Now, if car speed increases, if the car is going faster than this value square root rg tan theta. If the car is going faster, then this an will increase. It will increase. It will increase. So you need more force towards the center, right? So right now we have n sine theta, right? We need to increase it. And how it will be increased? That the car has the tendency to slip up the incline, because this force is not enough to provide this acceleration. So it will try to decrease this acceleration by increasing the radius, and the car will have the tendency to go up. So here, car wants to slip up, right? The car wants to go like this, slip up. And to stop that slipping, if there is friction, the static friction will apply down the incline to stop the slip, and the static friction will apply, which will be Fs. It can be anywhere between 0 and mu Sn, right? And then what happened in this direction, you will have some more force, and this angle is theta, so you will have Fs cosine theta, and then this will be equal to m v square by r, right? So again, if the car starts going faster than square root rg tan theta, the car will have the tendency to slip up. And if there is friction on the track, and in reality the race tracks have a lot of friction, so the static friction will start applying down the incline to stop the slip. Now, the other case, if the car speed decreases, the speed gets below square root rg tan theta, then the car will have the tendency to slip down the incline. So now the car wants to slip down like this. So slip down tendency. It is not slipping, it has the tendency. So if there is no friction, the car will slip down because you are not going fast enough, right? You must have heard about this Maut Ka Kua, right? So you will know what I'm talking about. You should go and watch that game, right? So slip down tendency. So in this case, the ground will apply a static friction upward, and that will be anywhere 0 and mu Sn. Okay, anywhere between 0 and mu Sn. And now what will happen? You are going slower, right? And the force in this direction is n sine theta, right? And this force here is going to be Fs cosine theta, So n sine theta is more than v square by r, because your v is reduced, v is going down, right? So your an has increased, right? Sorry, it is decreased also, right? So if an is decreased but n is same, so n sine theta is more than mv square by r, right? So the friction that applies up the slope to stop the slipping down, it will have a component in the opposite direction. So what will happen? You will have n sine theta minus fs cosine theta equal to mv square by r. And that is the equation when you have speed less than this sweet spot, square root rg tan theta. So what do we see? There is a range of speed of the car if there is friction on the track, that if you drive between this minimum and maximum speed, the car will not slip. So at v equal to v minimum, if you are going this minimum speed, what is happening is you have the friction force Fs is mu Sn, right, which is the max value upward, because at v equal to v mean the car wants to slide down the slope, And if the car is going at the maximum speed, the car wants to slip up the slope, and in that case the friction will try to stop the slipping, and the friction will be Fs equal to mu Sn, and which is also maximum. So at max and at min speed. So you see how the direction of friction depends on the tendency of movement. Now, let us talk about kinetic friction. Kinetic friction is always mu Kn, and kinetic friction is when you have slipping, right? Or there is relative speed, right, is not zero between body and surface, and the direction will be in the opposite to the way the body is moving or slipping relative to the ground. So let us look at these two examples. So kinetic friction is always mu Kn. It is in the direction opposite to the slipping or relative motion. So look at this example, the first example. The surface is moving to the right with the speed Vs, and the block is moving also to the right with V block. But V block is more than Vs, so the relative speed is not equal to 0, so it is slipping. Right? So friction will be kinetic. But what about the direction? The friction on the block will be this way. This will be Fk on block. Okay? Because the block is moving, to right relative to the ground. This is very important. Relative to the ground. Okay, and you will see it in the second example. So let us look at this second example. The block speed is less than the surface speed. The block is moving to the right, the surface is moving to the right, but the block speed is less than the surface speed. So the relative speed is not equal to 0. So same thing, you have slipping, so you have kinetic friction. No doubt, that is easy. But what about the direction of kinetic friction on the block? So the direction of friction will be to the right. And that is what you have to understand, that kinetic friction on block, and this friction is being applied by the surface Fk on the block, because block is moving to left, and that is very interesting, to left relative to surface, and that is something you must understand, right? The kinetic friction is not opposite to the block velocity. It is in the opposite direction to the relative velocity of the block. So in the first example, if you are standing on the surface, right, if you are standing here, right, so you are seeing the block is moving towards you and you want to slow it down, so the friction is to the left. But in the second example, if you are here, right, if you are standing on the surface, you will see the block is actually going backward. Block is going to the left, right? Because V block is less than Vs and the difference is negative. Negative means less than 0. That means the block relative speed is to the left. So the kinetic friction on the block will be to the right. So I hope you understand this difference. Now, one more example. Look at this. You have a moving surface. The speed is Vs. Then you have a block 1 on the surface and the speed of the block is less than the surface. Then you have another block 2 on block 1 and that is moving faster than the block 1. So let us look at the kinetic friction on block 2, right? So on block 2, because V block 2 is more than V block 1, right? So this block 2 is moving, the V block 2, right, is moving to the right with respect to block 1. So block 1 would try to stop it. So here Fk1 on block 2, and Newton's action reaction principle here, block 2 will apply the same force on block 1, and that will also be Fk1 on block 1. They are equal and opposite. Okay, but you have to understand that when you are looking at that this is on block 2, I will write more by block 1. This force is on block 2 by block 1, and this force Fk1 to the right is on block 1 by block 2, right? Because block 2, so I will write block 2 is moving this way relative to block 1, right? So the relative motion of block 2 is to the right, so the friction is to the left. The friction is, the Fk is to the left, because relative motion is to the right, and on block 1 it is opposite. Now let us look at block 1 and surface. So V block 1 is less than Vs. So just like we talked this example here, so let's go back here. V block 1 is less than Vs. So just like this example, V block less than Vs, what will happen? The surface will apply a friction force Fk, I will call it prime, Fk prime, and which is the friction on block 1 by surface. Okay, because block 1 is moving leftward relative to surface, and this is again important to understand that, because block 1 in absolute frame is moving to the right, but because its speed is less than the surface, so relative motion is to the left, and the surface will apply a friction to the right. So we talked about static friction, kinetic friction. Now let us look at some past year questions. This is from JEE 2022 Advanced. In this problem, you have a sphere, a solid sphere, radius and mass they are given. The question says rolls without slipping, right? There is no slipping. That means the friction will be static friction. And if you do not get it right and you apply kinetic friction, after that you do everything right, your math, your equations, your formulas, but you will get the wrong answer. So what will happen, that at this point here, like if you draw it at this point here, you will have static friction, right? Fs, and Fs is not equal to mu s into n always. Okay, so you will just leave it Fs. But now the question is, would it be up the slope or down the slope? So start with no friction, right? So what is happening at this point, you have mg, and that mg has a component this way, right? So that is mg sine theta, right? And this force here, that is 1 Newton each. So this is 1 Newton and this is 1 Newton. So this force and this force cancels out, right? So mg sine theta, a weight component, is pulling it down. So without friction, this point has the tendency to go down. So this point here, without friction, this point wants to slip down, right? Wants to slip down. So the friction will be up and the friction will be Fs. So do not write that Fs is mu into n. If you do that, then this problem will be wrong. Okay, so that's what we learned. And you can see the full solution of this problem in my channel. The link is given in the description for this video. Another problem from past year exam from 2021 advanced. Again, you see it looks simple, right? You have a cylindrical object, okay, and you are applying a force F. Read all the question, and the most important thing relevant for this video is rolling without slipping. So rolling without slipping means again static friction, right? Fs. And do not say that it is mu n, right? It can be, but it cannot be. So if there is no friction, the force, right, to this point here, so this point here, right, if no friction, right, because of F, right, this point, so I'm talking about this point on the body, this point wants to move or slip to the right. So the friction will try to stop that, and the friction will be like this, Fs. And remember that Fs is not equal to mu s into n always. So just write Fs. Okay, so again, link for this problem solution is also in my description. So I hope this video helps you understand the difference between static and kinetic friction and how to apply that correctly.